So good morning, everyone. We're very happy to have you here. So today we will have an amazing webinar about false codling moth management. And we have also the pleasure to have insect science with us today. So the first person I would like to introduce is Professor Dr. Vernon Stein. He's the managing director of insect science and have a PhD in FCM control. The second person we have today is Martin von Niekak and commercial. And the last person we have is Martin Mombarbo. He's the managing director of Elephant Vert, East Africa.
Thank you, Benjamin. Nice being here today. So at Insect Science, we work with semiochemicals, and semio means signal or information, and chemical means molecule. So it's just information through molecules. And this can be split up.
Oops, sorry for that. Please, someone cut your mic, please. Thank you.
Oh, not a question. Okay, so semiochemicals can be broken up into two main parts, either pheromones, which is the communication between individuals of the same species, or allelochemicals, which is the communication between individuals of separate species. A good example of this is a fruit or a tree. As the fruit ripens, it starts giving off different scents. And these scents can be picked up by the insect and then the insect will move towards that crop, knowing that it is phenologically mature and it can do damage and complete its life cycle within that crop. So that's allelochemicals. A good example of pheromones is, for instance, a female FCM releasing a pheromone and then drawing the male FCM towards her. That pheromone will sit as a molecule on his antenna. It's a lock and key system, so the molecule goes into the sensor, and when it switches off, there's an electric signal that goes to his brain saying, I have found the trail, and it can move towards the female. Next slide, please. So today we're going to be talking about false codling moth, which is at the left bottom corner of the screen. But just remember that we also have experience in many different moth systems. So if there are more general questions at the end of the webinar, feel free to ask them as well. So today for false codling moth, it is quite an important pest because it does direct crop damage to flowers, mangoes, avocados, and about 56 other cultivated fruit and vegetables. I don't even know that many, so you can almost assume that FCM is almost on anything that has a fruiting body. It also creates a lot of damage. In South Africa, it can lead to about 100 million rands worth of damage every year, just based on its direct crop damage. But we lose many more millions because we're not able to export fruit to other countries. It has a very quick life cycle, and at temperatures above 25 degrees, at about 26 degrees, its life cycle can be as short as 30 days. The female also lays many eggs and can lay between 60 and 150 female eggs in its lifetime, and then that causes quite a lot of generations per year. So in citrus in South Africa, we know it has 6 generations per year, but that's because we've got winters in South Africa and the temperature drops, causing a break in its development. However, in Kenya, and especially in roses, with the temperatures remaining high, it doesn't go into any breaks of that generation cycle, and we can have up to 12 generations in flowers per year. And then lastly, because it is a phytosanitary pest, being mostly in Africa and not in other regions, there are stricter regulations that we have to adhere to before exporting any of our crops. Because of this, it's important to not just use one control type, but trying to have a control at each stage of the life cycle, because we need to get a very low and good control. So before we go into the management of a pest, we first need to understand how to identify it. So the two stages that we'll would be dealing with mostly are larvae and the adult moth. So for the larvae, we can use acetyl map. Acetyl map is like a fingerprint for a moth. It is very specific. Every single species has acetyl map that is unique to it. So for instance, here we can see the first segment where you can see the spiracle, the little round circle, that's its breathing hole. And for FCM, it's above the L1 group, that dark patch. In other moths, it might be next to it or underneath it. So a good resource to use is LEP Intercept. It's a website that has all the acetyl maps of the important economic pests, and it teaches one how to use these acetyl maps for identification. A good characteristic to look for false codling moth is also the anal comb. You can see that on the last segment at A10, and it has to be present for it to be false codling moth. Many of the species that are often misidentified as false codling moth does not have this anal comb. So that's a good character to look for. To go into more detail with the acetyl maps and knowing how to identify all the different species, you can look at LEP Intercept, as I mentioned, or Stellenbosch University has an online course that they provide every year that delves into these characteristics. For the adult moth, it's a bit easier to identify as it has a very characteristic C shape on its forewing with a little dot underneath. So many people see it as a question mark. If you see that question mark on the forewing, you know it's false codling moth. And then for the males, they have a black tuft on their legs and also an androconia or scent gland on that hind wing. False codling moth is the only economic pest that has that androconia. So that's a very good characteristic to use. However, if you're trapping them on a sticky liner, it might be quite difficult to see those two characters, and most people rely on the C shape or the crescent shape on that forewing. So now that we know how to identify the moth, we can go into its life cycle. This is in table grapes, but it'll be the same in roses. So the egg gets laid on the outside of the fruit, and the first instar bores into the fruit. The fifth instar comes out and then drops to the soil. For the first few days, it is a pre-pupae, where it is very sensitive to soil pathogens such as EPNs and EPFs. But after becoming a full pupa, it becomes more resilient. A few days later, the adult moth emerges, and it will become sexually active at the end of the first day. It is important to remember that false codling moth is a flying or winged insect, so it can move large distances, and it will move between different crops, different cultivars, and different greenhouses. But it will only move in search of food or mates. Here we can see false codling moth flying in a zigzag pattern through the orchard. It will, in that way, come in contact with a pheromone. It will ping on his antenna until he locks onto that plume and moves from a low concentration to a high concentration until it finds the female, and this life cycle can start again. So the first step of false codling moth management is monitoring. We need to know where the insect is in space and time. So where and when is the insect? To get a good handle on this, we need to put out a grid of traps. So for instance, in greenhouses, you would like to have a number of traps per greenhouse. Different cultivars, you would want its own trap. We want to know in which cultivar false codling moth is and when. You can also put additional traps out for the monitoring of the males if you have any changing variables. For instance, if you have an open side to a greenhouse, you would like to put another trap perpendicular to that changing variable so that we can see where the population is moving from. A good example is this map that I've put here. We originally thought on this farm that the pressure was coming from the top right of the screen at A7. We put out our traps in a grid-like fashion, and then after 3 weeks of trapping, we saw that the pressure was actually coming from the bottom at A6. That allowed us to change our strategy and start doing interventions early season at the bottom of this map. allowing for more effective control. So for false codling moths life cycle that we've already seen, we can identify 3 different places where we can have an intervention. The first is to prevent the egg deposition, so prevent egg laying. The next is to stop larval maturation, and third, to stop the pupae. Those are the 3 places that we can have an effect on FCM's life cycle. So at Insect Science, we believe a very important stage to control is the mating. We don't want false codling moths to become mated and lay eggs. This is a very important point to stop or break. The reason for this is, as I've mentioned, false codling moth can lay up to 130 female eggs per female. So you will start off the population with 1, which will then go to 130 females. The next generation, you'll have 130 going to 16,900. And by the 3rd month, you can have as many as 2.2 million moths in your system. So one has to have a control intervention here to stop this rapid growth of the population. If we can have even 90% control here, we can stop this exponential growth. Therefore, we will try at Insect Science to stop the male reaching the female. And if we can stop the male finding the female, we can stop her laying fertile eggs on the roses and stop their population. To do this, we use mating disruption, which is the broadcasting of the female pheromone within an agricultural landscape so as to decrease or interfere with the reproduction of the pest. Mating disruption can manifest in 2 main ways, which I'll go into in more detail. So this is a diagram from Miller and Gutt, and it shows all the different ways mating disruption can work. Each block is a different theory on how mating disruption manifests, and each asterisk and the darkness of it says how much evidence there is for that theory. So today, I'll only be talking about the 2 main ways it can manifest, which is competitive attraction and desensitization or non-competitive mating disruption. So if we start with competitive attraction, it is here we've got the dispenser releasing pheromone, and you must think of pheromone as these little stripes, these little molecules moving in the air. Just as like that, the female also releases a pheromone, and the male will then move through the system in search of that plume. He will move from a low concentration to a high concentration. He will fly all the way to the dispenser, notice it's not a female, and then he will continue his search. With competitive attraction, the male will continue to search even after finding the dispenser. So the dispenser is competing with a female for the male's attention. Therefore, you need to have more dispensers than females in the system to have adequate control. An example would be is if you have 1,000 dispensers and only 10 females, the chances are very good that the male will find a dispenser rather than the female, causing high mating disruption. But if you only have 10 dispensers and you've got 10,000 females in your system, the chance is much better that a male will find a female rather than a dispenser, leading to very poor mating disruption. The other mechanism is non-competitive disruption. So with the same system as before, again, the pheromone will be released from the dispenser, but here at a much higher concentration, normally at 100,000 times higher than what the female can produce. The female will be releasing her pheromone, and the male again will be in search of that plume. He will follow it from a low concentration to a high concentration, but because it's releasing so much more pheromone than a female, his antenna will become saturated and he will no longer be able to detect the pheromone, making him go and sit on a plant for the rest of the evening. You will then have his enzyme trying to break open those sensors again to allow him to start searching. Under this system, you don't have any competition between the dispenser and the female FCM. Therefore, you can have far fewer dispensers per hectare. Some products like XMed, you'll have as little as 40 dispensers per hectare, but you need to have a very high release of pheromone, like I mentioned, at least 100,000 times more than the female. But doing it in this way, you can have 6 months or even up to 10 months control.
Yes, perfect.
Yes, sorry for that. So as we have seen with Dr. Vernon, the life cycle of FCM consists in 4 major stages: the egg, the larvae, the pupae, and the adult. And the management can be effective only if we have a control intervention on every stage of the pest. So this life cycle, as we have seen with Vernon, it can range from 26 days to over 100 days sometimes, meaning that the FCM can produce from 2 to 12 generations in a year. This is influenced mainly by temperature, but not only. We have also things like humidity. For all the growers that are here today that are growing their crop in tunnels, you can remember that at 25 degrees, we are considering the life cycle takes 1 month. So that means the greenhouse are very conducive environment where we can have 10 to 12 generations in a year. The eggs are quite small and sometimes difficult to see in the naked eye. And immediately after hatching, the larvae will burrow into the rind of the host plant. That makes most conventional molecules a bit difficult to work. But we have many solutions such as virus, bacteria, conventional molecules, and then also you have parasitoids that are attacking eggs and larvae. Once the mature larvae spin the cocoon and pupate before so from the larvae stage it goes to the cocoon stage. This is usually in the ground surface where you have many EPF and EPN available in Kenya. And then the pest arch into an adult where we have to disrupt the mating with the 2 solutions that we have seen that are either attract and kill or mating disruption. So I think it's also good to know what are the FCM doing in the tunnels. When we are farming in tunnels, roses or capsicum, you have to use the nets and plastic tunnels. They should be in very good condition, no tears, no holes, because to prevent incoming population inside your orchard. You should do very regular checkup to make sure that the nets are in good condition. And for growing, you also need, of course, good temperature, good humidity, and good airflow to prevent pathogen. All of these are conditions that are very good for the FCM as well, unfortunately. So it's good to know, as I think Vernon explained, the adult is not here to feed. It's only the larvae stage that feeds on your crop. But the FCM adult, so the male, he comes here looking for mating, and the female comes here to lay the eggs into a host plant. You can see on the slide there is some explanation of the life cycle depending on temperature. It's not the only characteristic that influence. But yeah, as you can really see, 25 degrees, you can see sometimes that the life cycle is less than 29 days. We have also seen that sometimes in a greenhouse, the female is able to delay the egg laying. So between the mating and the egg laying, it can take 3 weeks or sometimes even more, 6 weeks or 8 weeks. And sometimes the female is waiting for more conducive conditions. So you can, for most growers, we can see the traps, they can be silent in December, they can be silent in January, even beginning of February, still silent. Come the rain in March, you get the numbers are going up. So you have to be careful and aware of that. Another point to note is that when you spray a chemical, sometimes you will stress the female. And it has happened from our visit in the field that sometimes we meet growers, they are telling us, I have sprayed my chemical today. The next day, I see so many larvae and eggs. This is because the female was stressed and it moved into a survival mode. So yeah, as I explained, the male respond to the pheromone, and the female respond to volatiles. So it's very important to have good quality pheromone. Because remember, when we are using a pheromone, we are looking at having an information. So you need a very good pheromone that has consistent release from all the time is supposed to work. Being in the market, we have pheromones that are going for 8 weeks, and we have pheromones that are going for even up to 6 months. What you need is to have consistent pheromone release throughout that time. It's critical because I have seen some growers, they have a pheromone that will release a lot and they will catch a lot of FCM for the first few weeks. And then after 2 weeks, 3 weeks, they already see the decline in catches, and yet they have not changed anything in their approach. So that's very important to have high quality pheromone with the exact ratio, because those pests, they respond to that smell, and every time it is not exactly the right smell, they will know that it's not the right pest and they will not respond positively. So when it comes to control, you need a holistic approach on all stages, as we have said, and there are a few questions you need to ask yourself. What molecules can you use? Which stage of the life cycle you are targeting? And look at your sanitation practices and spray on the eggs on the larvae stage. And then there is 2 new solutions that you can use on the adult stage that we will develop later. So as we've said, the larvae goes and dig inside the plant, the flowers, the fruit, whatever you are growing. So it makes the contact very difficult. You need something that will be ingested by the larvae when you are picking a chemical. And for that, you have solutions like virus, you have solutions like BT, and you have a new solution called Venerate that is also metabolites from bacteria. And then you have also many chemicals that have stomach action. You need to ask yourself if it's safe for the predators and the pollinators. You will need to check at how long you're looking at controlling, because you might want to have some residual effect, because if you spray today, you need that residual effect for it to reach contacts and good coverage. And of course, at all time, very good sanitation practice. So in the next slide, we will see an example of IPM program. So this is the pyramid of IPM that you're all aware about. It always starts with good agronomic practices. And so it's recommended for you to train your staff with pest ID, have good pictorial on the walls, in the production, in the greenhouse, in the pack house, everywhere. Know the life cycle of your pest. Try to adapt the timing of your activities. We know it's a nocturnal pest, so that is very active from 5 p.m. onwards until midnight. Try to protect your microbial life in the soil, your beneficials. They are also helping you in managing the FCM. And it's always good to have a good quarantine area. So you know when you find an egg, you know exactly from which greenhouse it comes from, and you can have even good traceability. When it comes to decision, there is the monitoring. As I said, good pheromone quality is key with the good ratio, and we suggest that 4 traps per hectare should be enough. Every trap mimics like 1 female, and the ones from Insect Science are loaded with enough pheromones to last for 5 months. And the molecule of the plastic of the pheromone and the molecule of the pheromone are adapted to release continuously at the exact rate. That's critical because you're looking at having correct information. In terms of mechanical control, there is the new system approach presented by Kefis, but you need to have a good greenhouse cover, no tears, no holes, and you need to tuck the cover in the ground. You have to inspect this on a very regular basis because it's happening a lot that you have some damage on the greenhouse. The netting needs to be insect proof. It's below 20 mesh size, the one that are recommended by Kefis. And as much as possible, you need to implement a double door system. Light traps, as we have seen, they are not the best when it comes to controlling FCM, but they can help, and many growers are using them. And then finally, agrobacterium. You need to be very keen at removing agrobacterial, and you have a few biostimulants that can help you also to build resistance and help the plants to recover from them. In hydroponics, you can always boil the soil, the media that you are using, because we never know what you can find in that soil. So biological, I feel we spoke about it, but it's always good to remind you. Apply EPF and EPN, entomopathogenic fungus and entomopathogenic nematodes, for those who don't know. Use the virus. It's very good because you can infect larvae through the virus. Venerate SC, so it's a very good metabolites based on bacteria that will work through ingestion and destroy the mouth system of the pest. It's working well also on sucking pests, so it can be a very good residual effect on FCM larvae. Release parasitoid. There is a parasitoid that exists. It's called Trichogrammatoida, sorry. I don't think, I have not seen it in Kenya yet. I don't know if you have IPM suppliers today, but you might want to look at it. It's parasitoids that eat eggs and larvae. And then for the adult stage, we believe that's the most critical one because we spoke about it, how difficult it is to achieve contact at the caterpillar stage. So adult stage, we have two solutions that my colleague will speak more about. One attract and kill and one mating description. Then the last part of the IPM program is, of course, to use chemical pesticides, but always ask yourself, how does this chemical work? What is the mode of action? And make sure that it is not only contact, because you will have very high difficulties to reach contact. Usually the ones.
Thank you, Martin. Thank you so much. And now we will talk about the two new solutions of adult stage with Martin.
Good afternoon, everybody. It's a privilege to be able to present to you guys again and to speak to you. Yeah, let's get going. Next slide, please. One of the most important things that we always talk about, and my colleagues spoke about it now, is the importance of understanding ratios of pheromones and the quality of it. Each insect, the ratio is very, very important. Otherwise, you would be catching a lot of other insects in your traps. So each insect has a very, very unique ratio of pheromone that he responds to. So the quality of your lure is important. So not all lures are equal. Things that come from China, things that come from people that you never meet or never see, might not be catching enough FCM to truly represent what's happening in your orchard. So if you are going to do monitoring and you need the best answers to your questions you're asking, first start with good quality lures. So one of the things that insect science do is we research all insects, all methods of control, the whole stage of its life cycle, so that we can better understand where things fit in best to control. So here's just a diagram that shows everything starts with monitoring. Monitoring is the most important thing to tell you from there onwards the control practice that you've taken. Is it working or is it not working? Even if it's mating disruption or attract and kill or chemical or anything you use, monitoring will tell you whether your practice is working or not working. So one of the products we're going to talk about today is Malex FCM. Malex FCM is also known as Last Call. In Kenya, it's called Malex. It's an attract and kill. So my colleague Vernon spoke to you about competitive. So Last Call is a competitive device. So what happens there is we put a lot of little sources of pheromones. So it's a high device, low release rate. So what that means is we're trying to outcompete the females for the male's visitation. So what this does is we're putting out between 2,800 and 4,000 droplets per hectare. And the males will start to fly. They get very, very excited by the pheromone, thinking it's a female. They come make contact with the droplet. And then when they realize it's not a female, they fly away. But they've already been in contact with a chemical which will kill them within 5 minutes. So this is very, very important to understand that when you're dealing with a competitive moth, it's important to keep him competitive. You don't want to disrupt him with a competitive device. So how does this work? Simple example I can explain to you is if you are sitting in a room and a woman walks into that room with perfume and she walks around the table. Every time she walks around the table, your nose, you'll smell the perfume every time. And without you doing a conscious decision, your brain gets excited that it smells the perfume. This is exactly what competitive attraction or competitive disruption is. You want to keep them excited so that they really, really want to find that droplet, and they work really very hard to do it. So last call is manually applied to, go back, is manually applied to the plant by hand, like you can see on the picture. It has a calibrated pump head. So each person goes into the orchard and you apply the droplets to the plant. It will attract all the males, not the females. It'll attract the male of the FCM to the droplet, and once made contact, she'll die. So once the last call's been applied, it will last 4 weeks of attraction. It'll attract FCM for 4 weeks. So there's about 2,800 droplets per tube. One of the best practices we've seen in Kenya and in Ethiopia, where we work with the flowers, is regular applications of lower droplets. So best practice we found is 1,400 droplets every week. What happens here is you consistently having virgin droplets coming, virgin females competing, and you heighten the sensitivity of the FCM. And we've seen a very, very, very good effect in that way. So instead of applying it, waiting for 4 weeks to run out, you apply it more regularly at a lower dose, and you get a very good controlling effect there. One of the most important things is you see the droplet on that plant. That droplet, it must be that specific shape, and it must be applied in that place. So the shape of the droplet is important because that is the reservoir that controls the release rate over time. If you smeared that droplet flat, it would heighten the release rate, and you would increase the release rate of the pheromone, and it will be running out very quickly. The next important thing is we put it in that place so that your mechanical implements and people moving through the orchard don't come in contact with the droplet to smear it flat. You can put it on the leaves, but then it allows place for people to rub up against it and smear it flat. We prefer it there on that little branch, in that sort of place, and in that shape. The next slide will also show a similar one. So if you see the next slide, that's a little droplet on a branch where it can't be made contact. The moth has a landing platform to land and to make contact with that droplet. Okay, now we can talk a little bit about mating disruption. Mating disruption, the product's name is X-Mate FCM. X-Mate FCM is a non-competitive or desensitizing mating disruption. So what this means is it's low devices, but with an extremely high release rate. So what we've seen in the flowers, we can get away with between 40 and 80 devices per hectare, depends on your airflow. Airflow is critical to the movement of all pheromones for the natural insect and for the controlling device. So we have 2 types of X-Mate FCM mating disruption. One lasts for 5 months and the other one lasts for 10. The important thing about this is some are better suited for outside, for short crop cycles like chilies, capsicums, avos, those type of things. And the 10-month one is better suited for longer bearing crops like flowers, continuous bearing. So what's important here for the control of FCM in highly susceptible crops like flowers, continuous disruption is key. So you're bringing down, you get 90% control on 1,000 moths. When 1,000 moths become 100 moths, 90% control leaves you with 10 moths. And if you continuously suppress the population like that, you will have a much more successful control of a highly phytosanitary pest. So one thing we've learned as well with mating disruption in tunnels specifically is tunnels are extremely hot and humid. Pheromone doesn't work inside a tunnel like it does in open land. So open land, even if it's 40 degrees, it's still the air cools and moves towards the ground. Now go back, please. Still moves towards the ground. So what we found in tunnels is humidity. Humidity is always moving moisture upwards. So what happens there is the pheromone tends to go from the soil or from the lower part and moves in an upward direction. But because the lack of airflow inside a tunnel, it doesn't move laterally left and right inside the tunnel. It sort of moves up and up and up and up and tends to go and sit up top in the roof of the plastic houses. With net houses, this is different because you have airflow. So with net houses and you have a decent airflow, the concept will be a little bit different, but still not applying the device to the roof of the tunnel, still applying it lower, closer to the plant. Where in plastic houses, we're applying it there as low as 30 centimeters to 500 centimeters off the bottom of the plant in the area where you normally cut your roses. So there's those thick branches around there. Okay, you can go to the next slide. So this is a picture explaining where we used to hang the devices. Now, if you look at that tunnel up top there, it sort of overlaps each other so that the heat and the humidity can go out. This is the place where the volatiles of the roses escape also. This is where the FCM females are flying of what's going on inside the tunnel. But that device there, because of the heat and the humidity inside the tunnel, it's taking the pheromone up and out. And instead of falling down towards the plant where the insects are. So we're never getting the pheromone of the insect and the pheromone of the device to mix together. They are being separate. They're running like this. So one of the most important things is, how do we take this and put it into practice? What do we do? How do we, when we sit down, one of the most important things is take all the information you get given, put it together and decide which one of these things better suit your farming style, your practice and everything. Okay, but start every one of your control programs with monitoring, because that will help you see things with that you don't have to physically go and look for with your eyes. Okay. These monitoring traps need to be placed on the top of the plants. So if you just above your roses, sort of a half a meter above your roses is the right place to put them. Each trap must represent itself. What happens is sometimes we have 4 to 5 different cultivars in a tunnel, and we put up 5 or 6 or 10 traps. We count the traps and then we add all the FCM together, and then we say we have 100 FCM. But meanwhile, what happens is you have one trap in one cultivar that has maybe 95 of those FCM and the others only have 111. It just means that you must intensify your control strategy in that one cultivar because it is more susceptible than the other cultivars. So each trap must represent itself and the cultivar that it is in, and not add everything together just for the house, if that is clear. 4 traps per hectare is best for monitoring. So what we do is more susceptible crops, more traps, less susceptible crops, you could go a little bit less, but you have a high intensity crop, so more traps, the better. As Martin said, the insect science lure lasts 20 weeks. So identifying your control strategy, you have enough control products available to you to control the adults, the eggs, the larvae. And the most important thing here is it's a highly phytosanitary pest. To control that insect, you're going to use products to control all 3 stages of that life cycle. If you integrate your plan to control those, you will not have problems going forward. Other thing you must look into, agrobacteria is highly volatile and seems to have an oviposition attraction to females, which means that they look for the agrobacteria to lay their eggs on to complete their life cycle. Again, I come back to decide on your plan before you start your season or before you into the season. And then as the box gets ticked and as the season progresses, you automatically know what to do when these specific things happen. Okay. And then choose the best control strategy per life stage. A lot of generic products, a lot of cheap products have good labels, but are not good at controlling these things because they have not been tested. So be very, very careful of cheap knockoffs or products that are not being well researched in the control of FCM.
Thank you so much, Martin, the boss Martin, and thank you so much, Vernon. So it's the Q&A right now. You able to write any question on the chat, and I will read them to the speakers. It can be targeted to Martin, other Martin, or Vernon. So we have 5 to 10 minutes of questions. So I'm just waiting for your question in the chat. And of course, yes, I can see a lot of like this slide will be shared, and you will be also be able to find the webinar on YouTube and on our social media. So everything will be shared just after. Yes, Martin, want to say something?
Yes, as we wait for more questions, I have one. Usually we say that in the tunnels, we need to put the traps, the pheromone traps, half a meter to 1 meter above the canopy. And in the orchards like avocado, citrus, more in the top third of the tree where there is good airflow for good dissemination of the pheromone. Maybe Martin, you can explain, why is it not good to put the trap lower inside the canopy for the roses farm, for instance, hoping that the humidity will take the pheromone up?
Okay, so it's a good question. So first of all, for outside in open field, there's always wind and there's movement. So the pheromones progression there will be towards the soil, and then the higher it is, the bigger the area it covers. And that is important to do that outside. Outside, if you drop it lower, you don't get a big enough representation for the trap. Inside the tunnel, it's very important to not even be 1 meter above the crop, right above the rose tops, sort of 20 centimeters above the rose tops. It's perfect, because the pheromone, this is plastic houses, the pheromone of the natural female and the male, when they're flying around in and out of the flowers, will detect that trap and will go into it. If it's lower than that inside the plant itself, there's less airflow there and there's less movement for the trap. The trap is too rigid then inside the thing. So the best practice is just above the plant, and you will have enough attraction to them over there. Does that answer your question?
I have another question. Thank you so much, Martin, and it's also for you. Someone joined like X-Mail last call was described as attract and kill. How does it kill?
So last call is an attract and kill. The formulation is a grease like a glycerol formulation with a chemical inside. So Kenya, we use deltamethrin inside it. So deltamethrin is a contact chemical, so it's not systemic into your plant. So the insect has to physically make contact with a drop, and he makes, just with his foot or with his antenna, he makes contact with the droplet. He becomes sick before he dies, and when he's become sick, a natural female will not accept him for mating or for courtship, and he will die within 5 minutes. We've done extensive kill tests on very short touch times on the droplet versus extended contact with the droplet, and between 3 to 5 minutes, he's dead.
Thank you. Another question for you, Martin. Since the life plan of male and female are different, is there a time where we will find male alone in the greenhouse?
Say that again?
Yeah, sure. Since the life cycle of the male and the female are different, is there like any time we will find only male in the greenhouse?
Well, Vernon, maybe you must explain that.
No. Thank you, Martin. I'd like to come in there. So a really important point with false codling moth is to remember that they've got overlapping generations. This means that the egg will be laid by a female. In the first 3 to 4 days, she lays most of her eggs. Then as her life continues and she gets older, she will lay more and more. She will lay more eggs and have an egg laying window of about 10 days. So the larvae that come out in the beginning and the larvae that come out at the end, over time, they will stretch apart. So in flowers, you will then have overlapping generations, which means you've got some individuals that are eggs, larvae, pupa, and adults. So you will have each stage of that life cycle within the population. So for the question, will there be a time where males and females are separate? You won't ever have where you have only males or only females, but you might have sections where you have some of the population as adults and some of the population as larvae. That's why it's very important when you choose your insecticides not to just go with a contact that has a very short window of working, but something that has a longer working effect, like the insect growth regulator, which will stay active for much longer on that plant.
Thank you. And I think I have the last question will be, you changed last call from permethrin to deltamethrin in male X. Can you explain this move?
Yes, so we were forced by European regulations to change away from permethrin. Permethrin is being banned and Kenya doesn't allow it. South Africa's getting it banned. So most of the countries that we do business in don't want permethrin anymore. So they accepted deltamethrin. The efficacy of the two is exactly the same, but it's a regulatory thing that we had to do due to regulations of the export countries.
Okay, perfect. I don't see any more questions.
If I may just add on this, rest assured, because when you use a male X solution, you are very unlikely to find any chemical residue in your harvest because you are applying on non-harvested parts of the plant, as we have seen, on the branches, on the cut point of the roses. So you use very minimal chemical, and it's unlikely to have any residue.
Okay, perfect. I don't see any other questions. So thank you so much, everyone. Thank you, Martin, again. Thank you, Dr. Martin. Thank you, Vernon. So thank you, all of us, for having this webinar today. It's a real pleasure. Thank you, all of us, also for being here as a participant of this webinar. You will all find more information on our website. You can also scan the QR code that you have here to have access to the WhatsApp channel. You can find us on YouTube, Facebook, LinkedIn, and you have also our email address to email us if you have any questions. Thank you for everything for your time. I wish you a very good day, all of us, and we will see next year for a new webinar. Thank you.
Sandisani.
Thank you.